Equivalent expressions with negative exponents. Let's take a look at our first example here. There are so many options and so many different ways to start when it comes to expressions with exponents, but my brain wants to first add with the bases that are the same so that I only have one of each type of variable to deal with. So that's what I'm going to do. So I have an x to the second power and an x to the third power. Since those bases are the same, I can add 2 plus 3 to get x to the fifth power. I have y to the negative 4 and y to the 2. Since those bases are the same, I can add those exponents to give me y to the negative 2. I'm going to write both of those terms as fractions. Any number over 1 is itself, so if I write these two terms over 1, I'm not really changing anything. But the rule of negative exponents says that if it moves over the fraction bar, it changes its sign for its exponent. So having all of them set as fractions is going to be helpful, because at this point, now I can decide if I want to keep my exponent where it's at, or if I want to flip my exponent to the other side. So since this x to the fifth is already positive, I'm going to leave this guy alone and keep him where he's at. Since this y to the negative 2 is negative, I need to flip this term to the denominator, and then I will bring the 1 to the top. When I flip that, the negative exponent, as soon as it passes the fraction bar, it becomes positive. That is what the rule of negative exponents says. Then, to write my answer, I do x to the fifth times 1, which is x to the fifth. 1 times y to the second is y to the second.